In this lecture, we'll study the addition and subtraction in the form of matrices and also the multiplication as well. So let's start with addition and subtraction. Suppose you have two matrices. Although these are the square matrices, but the same concept applies for any matrix. Now, the condition for addition is that order must be same as it is. That means if the order of first matrix is 2 by 3, the other one should also be 2 by 3. If the first one is 2 by 3, the second one is 3 by 2, the addition is not possible, neither the subtraction. So this applies for both addition and subtraction. So whatever we do in this page is called for addition and subtraction, even though they mention it or not. Alright, so in our case, the A is 2 by 2. So they both are the same. That means add them. Now addition is quite simple. Just take the elements and add them together. So the first row, first column element of A to the first row, first column element of B. And same for other elements as well. Now the final matrix would have the same order as it were in the original matrix. The order of A plus B is the same as order of A, which was the same as the order of B, which was 2 by 2. As I mentioned earlier, that these concepts are not limited to square matrices, and that's why now we have kind of a different matrix that is not square because it has different rows and columns. So before adding, you need to find their orders. A has 2 rows and 3 columns, which is same for B. So adding the relevant elements together, this is the answer for A plus B. Please note that it does not matter if you add A plus B or you do B plus A, since the both are the same. Because addition, in addition does not matter if you do A plus B or if you do B plus A. Both is the same result. So since addition is commutative, that's why the matrix addition is also commutative. Now let's look at subtraction. The same happens with subtraction. You first have to check the orders. Orders must be same. The only difference is that now you have a negative sign instead of positive. So things will change here. Now we have plus signs in these two positions because the signs were negative. So 3 minus 3 minus 2 is actually 3 plus 2. And the same is the case for 4 minus 1. Now, similar to the integer addition or subtraction, 2 minus 3 is not equal to 3 minus 2. The same happens in case of the matrix A minus B is not equal to B minus A. But you can do like take a negative sign common. So 8 minus B is actually equals to minus B plus A. And if you take the minus sign common, it would be minus B minus A. So A minus B is equal to negative times B minus A. That thing works here. So if you want to see if it actually happens or not, you are welcome to solve the same example, but this time first find B minus A and then change all of the signs because there is a negative sign out there. And we will even study how to put this negative sign in the matrix next. So let's do that. Now we call it a scalar multiplication because obviously we are multiplying a scalar value with our matrix here. Now scalar means it's a real number. Uh, it does not have any variables with it, and it's like a constant value, right? So if that is the case, then that's all. K can be, positive or zero or less than zero even. Again, but again, K is a constant value. It is not a variable here. That's one example. Hence, negative 5 times A would be negative 5 times this matrix. And then we can apply the same formula we just studied. So which after simplification gives these results. Please note that in this case, there are no limitations on the order of matrix. We can just multiply any scalar with any matrix, literally. And also notice that the order of the matrix remains the same. So initially, the order of A was 2 by 2. And similarly, the order of minus 5A was also 2 by 2. The scalar multiplication can be applied. If the number of rows and number of columns are not equal to each other, that means it can be applied on